In our previous lecture, we discussed different types of dynamic loading, and today we will talk about the fatigue failure. Fatigue failure is a failure when a dynamic loading is applied on a body and that body get failed before the ultimate strength or the yield strength. This type of failure is called fatigue failure, and here this dynamic load means that the load P will not be constant. There are different types of dynamic loading. Following are its types. Fluctuating stress means that the sigma max will not be equal to sigma minimum, and both will have same signs. Similarly, for the alternating, sigma max will not be equal to sigma minimum, but they will have different type of signs. One will be positive and the other one will be negative. And for this repeated stress cycle, sigma minimum is equal to 0. And for the completely reverse stress cycle, sigma max is equal to sigma minimum, and they will have different type of signs. So these are different type of loads. When these loads are applied, it will bring the body to the failure before the ultimate or the yield strength of the body. Now these are not the failure criterias. So what we will have to do is to define another point that will give us some information related to the failure. So for that, first of all, let's discuss the fatigue life. So for that, you can see that from this point up to this point, this is one cycle. Similarly, it can have two cycles like this, or it can have three cycles like this, or it can have four cycles like this, or it can have n number of
cycles.
Similarly, for the alternating stress, it can have second cycle up to n number of cycles.
Similarly, the other two can also have a number of cycles.
Whenever a body is subjected to the dynamic load and that body bear that load for certain number of cycles, let's say for n number of cycles, and after these n number of cycles, the body will fail. So fatigue life is the number of cycles that will be passed by the body, or the number of cycles after which the body will fail. That will be called as fatigue life. So the number of cycles that the body will pass through before fatigue failure due to the dynamic load is called fatigue life. And fatigue strength is the strength of the body for a particular number of cycles under the dynamic loading. Let's say that fatigue life of a body is n. So for these n number of cycle,
The maximum stress that a body can withstand is called
fatigue strength, represented by SF. Let's take x and y axis, and for that, on the x-axis we have fatigue life or number of cycles, and on the y-axis we have fatigue strength, represented by SF. Now, so as we know that when there is a static load, this is the angle or the rotation, 0, pi, 2 pi. So when it is dynamic load, the stress will be like this, straight, or in other words, number of cycle for the static load is equal to 0. So when there is 0 cycles, the body will be exerted by static load, and for the static load, the strength will either be SUT, ultimate tensile strength, or SY. Now let's assume that the strength of the body is SUT. So for 10 raised to the power 0 cycles, the strength will be SUT. Now if we want a body of this material having strength equal to SUT, and we want this body to undergo a cyclic load such that number of cycle for that load is 10 raised to the power 1, then its strength will get decreased from this SUT to somewhere over here, because this body is undergoing variable load. So for 10 raised to the power 1, this will be the strength, and I represent this strength with SF1. And for 10 raised to the power 2, the fatigue strength is SF2, and so on. The fatigue strength of the body will decrease this way. Now when the number of cycles become equal to 10 raised to the power 6, you will see that there will be no further decrement in the fatigue strength. So the strength at this position is called endurance limit. Now let's combine these points. Now the strength at this point, where there is no further decrement in the fatigue strength, is called endurance strength, represented by SE, and the number of cycles for this strength can be named as infinite life. And this region, or this region strength, is for the finite life, and this is for the infinite life. And for that, the strength is represented by SE dash, called as endurance limit. Now if you want a body having finite life, let's say 10 raised to the power 4, you will have Ncurve. So you want to find out the fatigue strength for this body. For that, take this Ncurve like this, and at this point, after that, go horizontally to this point. So this will be the required fatigue strength for you. So this is SN curve for you. Then after that, so what is the endurance limit? Endurance limit is the fatigue strength of a body for infinite life, or when the fatigue strength will become straight and parallel to the horizontal or fatigue life axis. After that, let's discuss stress concentration factor. What is stress concentration? To understand it, let's take a shaft. This is the shaft. If this shaft is loaded with bending stress, so at this area 1 and 2, bending stress 1 at area 1 will be equal to bending stress at area 2. But if you can see that this area, the diameter is slightly smaller, and the diameter is small, then its cross-sectional area will also be small. And when this area is small, then you know that stress is equal to P by A. So when area is small, then this stress will be greater. So let's say this is the point 3. So bending stress in 3 will be greater than 1 and 2. Now if you see that this area 4 has the smallest diameter, and since it is the smallest diameter, so
The stress and that will be the greatest.
so bending stress in this area 4 will be greater than these 3. So this is called what? Stress concentration. Means that when there is a notch, let's say you have this type of shaft, so in this region, in this region, the stress will be same, but in this region the stress will be concentrated due to the decrease in the area. So for that, what we will have to do is to define stress concentration factor, and it is represented by Kf, that is equal to endurance limit of the body without notch divided by the endurance limit of the body with the notch. So this shaft, the endurance limit is this one, and for this shaft, this is the endurance limit. Now when you multiply it over there and divide this Kf over here, then SE is equal to 1 over Kf into SE dash. So this 1 over Kf can be represented by Kd So we can write this equation like this as well. Now here I want to mention one thing about this, that this will be the endurance limit of the critical location. Critical location means where the stress concentration will be maximum. SE will be for this area. Now, since we have in this case included only the effect of the notch, let's discuss some other things as well. And this is SE is equal to KB, KC, KD, KE, KF into E dash. So we can see that over here is SE is for a real body at critical location of a machine part in the geometry, which is this, and this SE is for rotary beam test specimen. You know that
If this shaft is rotating, you can call it rotary beam.
and if we want this shaft to test its endurance limit, then the strength for that will be called this. And here this rotary beam will be ideal when there is no notch and there is better surface finish. Ka is for surface condition, Kb is for the size modification, Kc is for load modification factor, Kd is for temperature modification factor, Ke is for reliability factor, and Kf is miscellaneous effect. Now why do we want to include these terms? It is because you know that this is for an ideal like rotary beam, and when you take another shaft or rotary beam that will have different surface finish than the earlier one that was used to calculate the endurance limit for that material, so its surface finish will be changed and the size of that rotary beam will also be different, and the load conditions under which it is tested that will be different, and temperature where the test was carried out will be different, and there will be a reliability factor as well introduced to the equation, and then at the last we have miscellaneous impact.